Hello and welcome to another differentiation video covering the A-level second year maths content. What this video is going to go over is the quotient rule. Again, much like with the product rule video, I'm not going to derive it. I'm just going to show you a few examples and how to use it. If you are particularly interested in the derivation, there are lots of video resources that you can find to do that. So, when do we use the quotient rule? Well, it's actually a lot easier to figure out because quotient is very really, in terms of thinking about it, another word for fraction. So if we have something that looks like one fraction divided by another, we can use the quotient rule. Obviously, you should check to see first if things simplify or if things or if you can write it in a way that means you don't have to use the quotient rule, then do so. But if you can't, the quotient rule is there. So if we use our UV notation that we used in the previous video for product rule, the quotient rule ends up looking like this. So we get the derivative of u times v minus u times the derivative of v. So notice how this is the other way round from the product rule and there's a minus in the middle, over v squared. This is not a particularly nice formula to remember, so conveniently they've put it in the formula book. Inconveniently, it's not in a particularly nice form. The formula book uses function notation. So it says if y equals g of x over h of x, then, or actually it says f of x. If f of x is g of x over h of x, then f dashed of x. Remember, the derivative of f is f dashed, so we can write the derivative of g and h as g and h dash respectively. So v is h, g is u, so we've got g dashed x, h of x, minus g of x, h dashed of x, over h of x squared. And that's how it's given to you in the formula book. It's not a hugely friendly form, but there we go. So again, I'm not going to go through where this formula comes from. I'll let you figure that one out for yourself. If you would like a starting point, think about writing our u and v like that, and then use the product rule. What I'm going to do now is just go through a few examples to show you how to use the quotient rule. So this is the first example we're going to look at. This one we'll go through together, and then, like on the previous video, I'll pop up the remaining 3 examples, then I'll write down the answers for you, and then I'll go through each separately. So our layout for this is very, very similar to the layout and presentation of the quotient rule. So we've got u equals x squared and v equals 2x plus 3. Now, unlike the quotient rule, this one, the u and the v, have to be this way round. The u is always the numerator, v is always the denominator. Some students like to sort of look at this and go, oh, I don't like using this formula, so I'm going to use the product rule. That's fine, you can do that, but I guarantee it will be more difficult than doing it this way. So, much like with the product rule, we differentiate. Derivative of x squared is 2x. Derivative of 2x plus 3 is 2. So now using our formula, we've got v times du minus, careful with the minus, u dv over v squared. With this example, we can see it's going to be relatively easy to multiply out the numerator and simplify. With other examples, it may be less so and may not be required, but knowing when to and when not to generally comes with practice and just some experience. It's very hard to say when you should, when you shouldn't. So in this case, multiplying out the numerator, we get 4x squared plus 6x minus 2x squared over 2x plus 3 all squared. That's going to tidy up to 2x squared plus 6x over 2x plus 3 squared. Now, we can also then factorize the numerator to see if anything cancels, but if you look carefully, you can see that it's not going to. This is enough. So here are the next three examples. As I said, I'll pop up the answers in a moment and then go through each of these separately. So here are the solutions. I'll go through each of them in turn, but again, if you find you got all these okay and you're happy with them, then you can just go away and practice. Looking at y equals e to the x over x squared, u is going to be equal to e to the x, v, it's going to be x squared, so du by dx is e to the x, dv by dx is 2x, so dy by dx is v du minus u dv over v squared. Now with this one, you can see we can factorize, but it's also very easy to simplify. And if it looks very simple to simplify, you generally should. So we can see every term has an x in, so we can cancel one lot of x's out. And we end up with x e to the x minus 2e to the x over x cubed. Next example, we have y equals sine 2x over x. So like before, u equals sine 2x. So u is the numerator, v is the denominator. Du by dx, differentiating this trig function, 2 cos 2x. This differentiates to 1. Therefore, dy by dx is going to be v du minus u dv over v squared. And this one, we don't have any cancelling, no simplifying to do, so we just leave it there. So with this example, the derivative of tan x is in the formula book, but you need to be able to derive it. And you do that by using the quotient rule. The thing is, quotient rule used for fractions. However, this isn't a fraction. So we need to write this in a way that we can then use the quotient rule. Now, some people go, oh, I'm just going to write it as tan x over 1. I mean, you can. That's not going to help. What we in fact do is use our trig identities. Tan is sine over cos. Now we can identify our u and our v. Differentiating sine x, we get cos x. Differentiating cos x, we get minus sine x. Oh look, we've got this idea of similarity. That's going to be very useful when it comes to simplifying. So dy by dx is going to be v du, which is cos squared, minus u dv, minus sine squared, over v squared. Now, minus minus, famously, is a plus. Now, some people now from here will split up the fraction and rearrange it that way, and that's fine, but if we look, we can actually make this much easier for ourselves, because sine squared plus cos squared is 1. 1 over cos is sec, so 1 over cos squared is sec squared x, and we're done. So as I said, this particular example may well come up as a proof in the exam. Show that the derivative of tan x is sec squared. This is how you do it. And that's the quotient rule. All you need to do now is go away and practice. Thank you for watching.